Let's go to Lico 834. Sum of distances in tree. For this question, it gives us a tree. It is represented using the 12-dimensional array ages and have n nodes. And let's return the array of for every this array has length n. For every node, the sum of distance between these nodes to all the other nodes. So let's look at the example. This is node 0, right? This node 0, to 1, it has distance 1. To 2, it has distance 1. To 3, it has distance 2. To 4, it has distance 2. To 5, it has distance 2. So it is 1 plus 1 plus 1, 1 plus 1 plus 2 plus 2 plus 3. So it is 8. Yeah, so this is 8. So for node 1, right? For node 1, it goes to 0. It is distance 1. Go to 2 is distance 2. And 3, that is distance 3, right? 4 is 3. And 5 is 3, right? So it's 1 plus 2 plus 3 plus 3 plus 3. So that is 12. So it needs to return every node to all the other nodes the distance sum. So we can do from every node to the BFS or DFS trying to get all of the distance. But doing like that, it will be O n squared, right? Or n squared times complexity. Because for every node, it go to another node. It will be n O n, but there are n nodes. But can we do something more efficient? For example, if we already calculate node 0, right? Node 0 to, we can use a one-time DFS post-order traversal to get all of the distance for this node. So if we already know these nodes, right? Let's look at node 1. We know node 0's distance. So how can we calculate node 1? Well, let's look at node 2, might be better, right? So if we already calculate all of the distance of node 0, let's look at node 2. So for the node 2, we will find for this part, actually for node 0, it's already being calculated, right? That is node 0 to all of the nodes distance has two parts. It's on its left and on its right, right? So for node 2, this part actually is contributes, we'll see, every node to node 0 will increase by 1, right? So every node to node 2 under this subtree will decrease by 1. So if we already calculate a node, then for its charts, right, one of its charts, every subtree nodes, those kind of distance will decrease by 1, right? So we'll see 0 to 2 is 1, 0 to 3 is 2, 0 to 4 is 2, 0 to 5 is 2, right? So you'll see 0 to this kind of subtree, it has 7, right? But 2 to this kind of subtree, right? It is 0 plus 1 plus 1 plus 1 is 3, right? So we find the thing, it is 7 minus 4, right? So what is 4? 4 is the count of this subtree, right? So you'll see this subtree has 4 nodes. So for this part, it will be 7 plus 4. And so there are for this node 2, right? There is another part we didn't calculate, is the rest part. For the rest part, original what we calculate is that for node 0 to 1, it is 1, right? And node 0 to node 0, it is 0. So it's 1 plus 0. But for node 2, it go to node 1 is 2 plus 1, right? So that means if there are totally there are n nodes minus this counts of this subtree, then for this part it will be the n minus counts plus this one, right? So that is 2 plus 1, that is 3, right? So we'll see this node 2 will be 7 minus 4, that is 3. Another part is 2 plus 1, that is 3. So that means if we already know for one node, one parent nodes, the distance to all the other nodes, we can use the calculations. We don't need to recalculate, right? So if we already have a node, for example, when we have a tree, if we already calculate, for example, a node, this kind of node, right, to the distance to the distance sum to all the other nodes, and then we should be able to get its child easily, right? So the child will be this counts, this subtree counts, right? So it will be actually the distance sum of, for example, A, right? Distance A minus minus count, this count B, right? Count B, these subtrees. And so for the rest will be N minus count B, right? So if we know a node, the distance, we can just use this formula to calculate its child's distance sum. So that means that for every node, we should also get the counts, right? So we need two arrays. One is distances, which is to all of the other nodes. So we use a post or traversal. And another is a count array, which means for every subtree, what is the node size, right? And in this case, if every node we know its counts, this one that is the minus counts, right? This part, and then this part it will be plus n minus size, right? So let's write code for this. We need two steps of DFS. So since the second transition is from this parent to its child, right? It will be a pre-order. And the first DFS is a post order because we want to see the counts which contribute to its parents, and also the distance contribute to its parents. So that's from these edges we compose the trees. We use this tree equals new list n. So we can do for instead of use for, we can use arrays set O, right? Set O, and the tree K goes to new array list. Then we convert these kind of edges to tree. So we know we need two arrays. One is distance sum by distance. Well, we are so this distance sum for the first DFS, what it should return is get every node subtrace choose distance sum. So that is for example, we have this kind of A, right? So that will be this node to all of its childs, the child nodes for this subtree the distance. And we are going to reuse this for the first DFS because we only get the subtrace distance sum. And for the second DFS, we are going to transit this distance to the result. So will be new int n. And we also need another, as we said, we need another array called count. Means for this subtree, how many nodes it is. So we'll say DFS, right? So we need a DFS1, okay. Tree. We need a parameter that is root, right? And we have parent one. Actually, it's not necessary to start from zero, right? Because every node we can treat as a root, and parent. And what we need distance array, right? And we need count array. So after but DFS1, right, we get distance. Distance will be we get every node distance to every subtree, right? Every subtree, every node has a subtree as a root, right? A subtree's node root to all its children. Distance sum, right? Distance sum, and also count. Count is for and every subtree is count nodes, right? Subtree node. So this will be the first DFS. We are going to use the postal order traversal to do this. And we are going to have a DFS2. DFS2 is that do the transition. If already know the parents, we are going to know its child, right? So you pass the same parameter from root and this parent distance and count. So after DFS2, we will fill distance array to get a result. In the end, we return distance. So we need two DFS. DFS1, right? DFS1 is we need a list integer as tree, right? And the current and the parent and we need a distance array and count array, right? So the thing is that we need this count current at least to be one, right? And for every next int next in tree current. So if it is that next it's a parent, we should ignore, right? So if next equals parents, we should continue. Otherwise, we just DFS1 3 next current distance and the count. And after this one, we should have count current the path equal to count next. and the distance current well plus equal to mm, so for the distance, right? How can we get the distance, right? So um, every child will get the distance to all of its child, right? So, so to its parents, for every nodes, we are going to add one, right? So will be the count next plus distance next. And in the end, I think that's it. So this is the first DFS, and we need the second DFS is do the transition. So we need this the integer as this one is tree, right? And then in the current, in the current, and distance, int count. So um, let's get the size first. Int n equals to, of course, we can pass in the size n, so that we don't need to we didn't use this one, right? This one don't need n. We can pass n here, pass it n here, right? Into n. We don't need to when every recursive call we have to get a n. So we just for into next in tree current. If current equals current, we should continue. And then distance next equals distance current. We should for this one we should minus, right? Minus count next. And we should also that this is for all of for this next this subtree which is rooted at the next, the distance will decrease by the count next, and for the rest will increase by n minus count next, right? So we should recursively call DFS2. So this is the pre-order traversal to to traverse all the nodes, right? Next, current distance count, right? So this will be the code. For every stack overflow. If current, the next equals parent, not current. Um, doing like this, we have traverse actually twice, right? Post order and pre-order. So both will be ON time complexity. And we have a tree space is also ON space, right? And let's write a Python code to this as well. Let's have tree equals this one for in range and for age in ages we are doing the tree age 0 append age 1, and we have tree age 1 append age 0. So we compose the tree. Then we need for some distance array, and count array equals this one multiplied by n, and both will be initialized less than, right? So we are going to have a DFS1 tree 0 minus 1 distance count, and the DFS2, right? 3 0 current distance count. We can have n in it because for the second DFS we needed this, right? In the end we just return distance. So DFS1. So we're going to have tree as the list of list and int and int current current is int current current int, and anything else distance. Distance is list of int, and count is this list of int. So we know we have a count current equals 1, right? Because otherwise we need to add in the end. So for every next node in tree current, what we do is that if n node equals current, we shouldn't continue. Otherwise, we're going to recursively call, right? So DFS tree and next. And current and distance and count. So for every we do the post order transversal for our current, right? We should add equal to count next node, right? Any node, and our distance current will plus equal to distance and node and plus count, and so this is the first DFS1. So we also need a DFS2. Here, we should have tree list. Actually, if we put this one outside, right? Don't need those parameters. Let's put this one here. Don't need this parameter, too many parameters, so we don't need these trees. We just need a current and a parent, right? For distance and the counts, we just put outside. And for our DFS, we just need a node in current. So DFS2, we can also have, because we can put this kind of in outside, right? So we can also have current int, current int, right? So what we do is that for a node in tree current, going to have if a node equals current, right? We should continue. Otherwise, this is DFS1, right? And otherwise, we are going to have DFS2. And now actually we should update distance array first, right? So distance next a node equals distance current um, minus count minus count a node plus a minus count a node. And then DFS2 a node and current. So this will be the code. So actually, we don't need to pass in these parameters anymore. Just has 0, -1.